comparison test, what you need to do, UN is given to you. UN is nothing but the end term of the series. So depending on nature of UN, on the powers of numerator and denominators of UN, you can find BN. Take their ratio and its limit and tending to infinity. If the answer of this limit is finite and non-zero, means the answer of this ratio's limit should be some finite value and it should not be zero. Then we need to check the nature of BN by P series. So in previous lecture we studied the P series. What is P series? How you can decide the convergence and divergence of P series. So BN will be surely in the form of P series. So if your BN is convergent, UN will be convergent. If your BN is divergent, UN will be divergent. But before that, you need to show that this ratio limit is finite and non-zero. If it is not finite and non-zero, this test would be applicable. So let's start with the example. So this is the first example for today. Test the convergence of series whose end term is this one. So you will have the questions of the same type. Test the convergence of series. Sometimes end term will be provided. Sometimes they will provide end term like this. Sometimes the series will be in the expanded form. Sometimes you will have the series in compact form also. So how to decide UN? In these two examples, these itself are your UN, this end term of the series. But for that expanded form, you need to find the end term of the series. Let's see these examples one by one. So here itself is UN, that is the end term of the series, that is n upon n square plus 1. What is the highest power of n in? So what is the highest power of n in the numerator for n?
1 by 2.
Half. N square root of n is n raised to half. So to calculate Bn, your n will be 1 by 2 here. What is the highest power of n in the denominator? 2. That is n square. So if we combine then, what will be your Bn? That will be 1 upon n square minus half. So it will be 1 upon n raised to 3 by 2. So this is the first part of the solution calculation of Bn. Once you will get Bn, what you need to do? You need to take the ratios limit. So limit of n tends to infinity un upon Bn is equals to limit of n tends to infinity. What is un? Un is this one, root n. So I can write it as n raised to half upon n square plus 1 whole upon n raised to 3 by 2. So that will go in the numerator after reciprocals like this. Now you can add their powers as base is same. So you may have here limit of n tends to infinity 1 by 2 plus 3 by 2, 4 by 2, that is n square. N square upon n square plus 1. Right? Now whenever you are coming across calculation of limit, here always limit is n is tending to infinity. N is tending to infinity, you know very well, to get it into the finite form, always try to bring n in the denominator. Because you know 1 upon infinity is what? 0. Right? So if you keep infinity like this only, you are going to get infinity upon infinity form, then use L'Hospital rule. So to avoid that, what you are going to do? Bring the n in the denominator. Now always in comparison test you are going to get the powers of numerator and denominator same. So let's divide numerator by n square and denominator by n square to bring n in the denominator. Or you can say you can take n square common also. So I am taking dividing numerator and denominator by n square. So it will be 1 upon 1 plus 1 upon n square. Right? So put the limit now. So 1 upon 1 plus 1 upon infinity. 1 upon 1 plus 0. So that is 1 upon 1? 1. So for the ratio you got answer 1, which is finite and non-zero. As it is finite and non-zero, one condition of comparison test satisfied. Now what you need to check? You need to check the nature of Bn by P series. So what can you say? By P series, is what? Convergent or divergent? Power is 3 by 2. 3 by 2 greater than 1. So it is convergent, right? Bn is convergent. And by comparison test, UN is also convergent. Our aim was to calculate the convergence of UN. As Bn is convergent, UN is also convergent. If Bn is divergent, UN will also be convergent. Okay, divergent. So that's it for this example. Let's see the another example. It looks complicated, but every example, what you need to do, you need to calculate the Bn by the highest power of numerator and denominator set. So here let it be UN. To calculate Bn, let's calculate the highest power of n step by step. What is the highest power here? N square. What is n square's power? 1 by 3. So square and 1 by 3 we combine and you will get 2 by 3. What is the highest power among them? N cube. What is power of n cube? 1 by 4. So total it will be 3 by 4. So combine them to convert into P series form. So what are you going to get? 9 minus 8, so 1 by 12, right? So it is 1 upon n raised to 1 by 12. This is your Bn. What is the next step? To calculate the ratio and its limit. So limit of n tends to infinity un upon Bn is equals to limit of n tends to infinity. What is un? This whole thing is your un. I am writing as it is 2n square minus 1 raised to 1 by 3. This is 3n cube plus 2n plus 5 raised to 1 by 4 into. Why into? Because this will be the denominator and by reciprocal again it will go in the numerator. So the value of Bn is 1 upon 12 and raised to the power 1 upon 12. So here you can't multiply directly these two things as you are having some odd powers here. So what you are going to do? You are going to take common the highest powers from them. As I said, you should take out the L such that most of the terms will have L in the denominator. As L will be in the denominator, what you are going to get 1 upon infinity will be 0. So for all examples, you need to follow the same. So here let's calculate step by step. I am taking n square common in the bracket. So you will get 2 minus 1 upon n square whole power 1 by 2. Upon here n cube common, you will have 3 plus 2 upon n square plus 5 upon n cube and whole power 1 by 4 into n raised to 1 by 12. Again distribute the power over the two terms. N square into 1 by 3 will be n raised to 2 by 3. And this term will be 2 minus 1 upon n square raised to 1 by 3. Same in the denominator. N cube to the power 1 by 4 will be n raised to 3 by 4. And here you will have 3 plus 2 upon n square 5 upon n cube to the power 1 by 4. Into this term as it is n raised to 1 by 12. Now you can observe this and this will get cancelled because this is going to, you are going to get for this n raised to 1 by 12 in the denominator, right? Because we got from that only this term. So this will get cancelled because you will get here n raised to 1 by 12 in the denominator, that will get cancelled with this. Now put the limit n tending to infinity. Wherever there is n, put the limit infinity over there. So what are you going to get? 2 minus 1 upon infinity. 1 upon infinity? 0. So 2 raised to 1 by 3. And then here in the denominator this term will become 0. This term will become 0. Only you will have with this 3. That is 3 raised to 1 by 4. So whatever the value it will have, we can say that this is finite and non-zero. That is our aim. Whatever the value you are getting, that should be finite. It should not be infinity and it should not be 0 as well. So So once you will get this finite and non-zero, check the nature of Bn by P series. So what can you say by P series? What can you say about Bn? 1 by 12 is what? Less than 1 or better than 1? Less than 1. So what can you say? Divergent. So Bn is divergent. So as Bn is divergent, what can you say about the UL? UL is also divergent, but you need to mention the test here by comparison test. UL is also divergent. Hope you understood this one. So this one will be complicated, but just take these step by step things common. Maximum power of n term, you should take out the common. That is the rule for every example, so that you can get the maximum n in the denominator and you can get the finite answer here. Now let's see the next example. So here your series is in expanded form. So UL is not provided here. Observe the propagation and tell me what will be UL here.
M plus 1.
That will be n plus 1 upon n cube, right? 1 cube, 2 cube, 3 cube, 4 cube, right? So what about BL here? What is the highest power of n in the numerator? N. That is n raised to 1. And what about denominator? N cube. So totally it will be 1 upon n square. So this is your BL. Once we will get BL, what is the next step? Ratio and limit. So what is the ratio? Limit of n tends to infinity. Un upon Bn is equals to. So what it will be? Limit of n tends to infinity n plus 1 upon n cube for the into n square. So this is very easy in this case. This n square and n cube. N square will get cancelled. You will be left with only 1 n in the denominator. So limit of n tends to infinity n plus 1 upon n. So here either you can divide numerator denominator by n, or what you can do, separate the denominator. So if you are separating the denominator, this is limit of n tends to infinity 1 plus 1 upon n. Put the limits here. 1 upon infinity is 0. So 1 plus 0, 1, which is finite and non-zero. As it is finite and non-zero, check the nature of Bn by P series. So by P series, what can you say? Yes. Bn is? Why divergent? N square is there, na? 2. 2 is greater than 1, so what? Convergent. Bn is convergent. So by comparison test, UL is what?